Good morning, good evening, good afternoon, ladies and gentlemen. Thanks for joining our webinar. It's the second webinar of Agiliway dedicated partially to Clojure and well, everything connected with Clojure delivery. And today we are happy to talk about rapid prototyping and fast delivery with Clojure. Just a few points about the structure of today's event. So first, you will see the introduction from myself. My name is Viktoriia Yaremchuk. I'm project manager at Agiliway. Second largest part of today's webinar will be delivered by Kostiantyn, who is our senior Clojure engineer. And then there will be a Q&A session. You can also use the chat or a QA section of the webinar. You can use the raise hand function in the bottom if you wanted to interact and ask any questions, and interact using chat, Q&A, and raising hand, and there will be a Q&A session in the end. So I guess we can start. Welcome again. It's my pleasure to be introducing the topic today, and also I'm really proud for having the growing community of Clojure engineer within Agiliway, and it's great to have multiple clients now that joined and basically involved us into their business success stories with Clojure, and there are multiple sub-projects within Agiliway working with our clients, and basically based on that we wanted to share our story, share our approaches, and I guess challenge these two like publicly known and popular legends about Clojure, that first of all it's hard to you know, find engineers because it's quite a rare technology stack, and you know, staff your product development and deliver. So that's already a myth these days. And second thing, that Clojure is a solid enough technology, solid enough stack for like solid products and fast delivery of them, and rapid dynamic changing environment. So this is the myth that Kostiantyn will be breaking today. Basically, the main goals of today's webinar would be laying the grounds and explaining why Clojure is so cool for quite a number of great you know, titans in the sphere. Like my favorite mentioning is Netflix, it's Amazon, it's eBay, and many others in the field that are now succeeding with Clojure. So with that said, it's over to Kostiantyn and our rapid prototyping and fast delivery story.
Hi everyone. So let's start with agenda. So first item will be why to use functional programming. Then a little bit of locality and simplicity, and how Clojure solves complexity problems. Clojure patterns that enable rapid feedback, and everything about REPL and how to dynamically reload your code. Clojure and Java interop, and Clojure best practices, and the QA session at the end. So let's start with why functional programming. So first of all, we need to answer a question: what is functional programming? And the key features of functional programming are basically one moment. So what makes a language functional? The first thing is required for for a language to be functional is that the functions are the first class object. It means that the functions can get another functions as arguments, and functions can return other functions and as a result. So basically functions are the values. Next thing is functions are mostly pure. That means that they have no side effects, so they are something like mathematical functions. They have the arguments and they produce some output with these arguments. And basically, a pure function that is called with the same arguments is always returns the same result. But why functions are mostly pure is because we need side effects to actually do something. And the last thing that is not always included in the description of functional programming languages is immutable data structures. But it is actually a crucial part of functional programming languages and functional approach. So let's go with a little bit of history. The first programming language, the first functional programming language was created in the late 50s. It was called Lisp, short for Lisp processing. It was it is called so because what it does is basically operates on single linked lists. So and its syntax is also consists of lists. So some notable features of Lisps. The code is data homogeneity. That means that the code, the syntax of the language is the same as the data structures that you can represent in this language. And other thing is evaluation strategy and macros. So it is actually enabled by this code is data concept, and we will talk a little bit more about this later. Also, other notable feature of Lisp is the funny syntax. So there are a lot of brackets, but if you know how to handle them, it's actually a very good thing. So here you can see John McCarthy. It was the developer of Lisp. Actually, he started this as more like a formal language to reason about artificial intelligence and computer programs, but later someone proposed him an implementation, and that's how Lisp was started. So he was a Turing Award winner, early AI researcher, and Lisp was actually used in the past. It was one of the primary. It was one of the primary things to develop an artificial intelligence in the early days that was based on symbolic logic, and it wasn't a very successful approach. And later Lisp came out of usage a little bit, but then when Clojure came out, it starting to reappear. So next thing about history is this guy. It is John Pecos. He was also a Turing Award winner, and he received his award for profound, influential, and lasting contributions to the design of practical high-level programming systems, notably through his work on Fortran. So Fortran is actually not a functional language, and it's quite opposite to all the things that related to functional programming. But when you receive a Turing Award, you should give a lecture, and the title of his lecture was Can Programming Be Liberated from the von Neumann Style, a Functional Style and its Algebra of Programs? So basically, although he developed Fortran, also one of the early languages, also dates back to 50s. He wasn't really happy with this approach, and even back in 70s, he already knew that it's not the way to go. So in his lecture, he described a functional programming concept that was later became a language that he developed. So a little bit from this article, this shows us a program for inner product, also known as dot product, just a mapping from two vectors into a scalar. Basically, you need to multiply corresponding components of the vector and sum it up together. So how it can be done in functional programming language? Here you have the definition of inner product as a composition of three functions. First one is transpose. So compositions is right to left. It's almost always like this. Then apply to all, multiply, and insert plus. And this is in abbreviated form, basically the same thing. So we can actually do it in Clojure, even if the language that was described by Pecos wasn't really a functional programming. It was a special subset of functional programming, is function level programming, and it is also known today as point-free style when you are not using variables directly. So here you can see there are no variables out here, only functions. So in Clojure, we can actually do the same thing. Here, the inner product function is a composition of, and to make it look better, we can actually define some helper functions. So here, as it was in Baker's program, insert, basically we can insert any function, and it will apply this function to all the arguments and store it in the result. Apply to all. Basically, it's it looks strange, but what it does, it applies an operation to a collection of collections. So basically, when we're transposing these two vectors, we have a lot of pairs, and we are applying a multiplication operation to these pairs. And with the help of these functions, the final definition of inner product looks exactly the same as, almost exactly the same as in example program. Also, transpose isn't really a default Clojure program, so we need to define it too, and we can easily do it like this. If you will try to define transpose in Fortran, for example, it will be much harder to do. So next thing that we want to talk about is persistent data structures. So what is it? Is a way of representing immutable data structures and also have ability to quickly create some copies and share structures. So basically we can update some data structure and it will return a completely new one, but it will be fast. So the underlying implementation is hash array mapped tries. It's basically very similar to a tree, but it has a much higher branching factor, and it uses some hash functions for comparison. So all these data structures and all the Clojure data structures and values are immutable. You may think that we need to mutate values and data structures, but actually what the direct mutation that is basically changing the bits in memory that is allocated to some data structure is not actually the thing that we want, because it doesn't really control. So we don't know when something was changed, especially if it is some kind of multi-threaded program, which nowadays most of the programs are multi-threaded, and we really need to control the state. So another feature of persistent data structures is cheap copies. So basically, when you modifying the data structure, you are creating completely new reference to another area in memory, and previous data structure is not affected. So we are creating copy, but this copy contains the reference to the part of the old data structure. In this way, we can still use, we can have a new data structure, but we're still using the old values in the data structure. So it makes much faster to update data structures and still having them immutable. So if we have something in our memory, it will never be changed. And the way to achieve this is the structural sharing. So here we have basically two structures. One is a vector with 7 elements. It is color-coded here. And another is vector of 10 elements. And the vector of 10 elements is actually shares the elements with the smaller one. So basically, we don't have to copy our the whole data structure to get to use the copy. So we have two data structures out here, but not all the values are copied. So performance-wise, it's actually very good. It's not as fast as conventional data structures, obviously, because for arrays or vectors, we have constant access, and so basically we can access any element in constant time. It doesn't matter what is the size of the array. But in the persistent data structure, so basically all persistent data structures resemble trees. So we have to look in depth, and it will be obviously it will be logarithmic complexity, but the branching factor is 32. So in depth 3 of this tree, we can have like 1 million of elements. So it's very much close to constant time. And if this is not enough for us and we really need this performance, we can actually use another feature of Clojure, that is transient. So if we have a persistent data structure and we want to do something with it, we want to mutate it, and we want to do it fast and efficiently, we can create a transient copy of it. The creation of this copy is constant time. We don't need to assign any new values to the memory. It just uses the values that is stored in the persistent data structure. And now we still can use the old API for persistent data structure to read from the transient ones, but we have to use a special API to edit it, so basically to mutate it. It is almost the same, but with exclamation marks at the end to signify that it is functions with side effects. So they are actually mutating memory. And then when we are done with all our mutations on this data structure, we can call persistent on it, and it will become immutable again. So we can safely use it as we want to. So next thing is locality and simplicity. So what is simple? Simple is something of one part. The complex is obviously a multiple simple things somehow interleaved together. So it's hard to tell how they interact. So other thing that is related to localities and simplicity is the state. State is the primary source of complexity, and the one reason why we are using persistent data structures and immutable values is to have as less state as we can afford. So basically we almost always need a state, but state creates all kinds of problems, and we are trying to control it. And Clojure have some approach to state and concurrency. I will describe in more details a little bit later. So the simple software is easy to understand, and what's important, it is easy to change. So we really want to make our software simple. When it became too complex, it will be really hard to modify it again. And the way to build a simple software is to compose simple component in a clear way. So how to make programs simpler? First of all, we need to program with values, not variables. So as I already said, mutable variables creates complexity. We don't know what will cause the change in this variable, and we don't know when it was changed and when it will stay the same. In Clojure, we have immutable values, and if some value was passed into a function, we always know that it will stay the same. And if it will be changed, in this lexical context. So we see where it is changing. And this change cannot come from another thread or something like this. Using pure functions instead of objects, stateful objects with methods. So, as I already said, in the functional programming, most of our functions have to be pure. It's not all of the functions. Some functions still need to do some things. They still need to mutate some states. They need to write into database, etc. But if we can build a majority of our functions pure and have only some handful of functions that changing some state and things like this, and we can signify this function to show that this function is not pure, we can have a better software. And isolating states. So basically, what we want to do is, of course, we need state, but we can create our programs in a way that state is isolated in a single or a few parts, and all functions are pure, and the changing of state happening basically in a single place. So in the typical object-oriented programs, we have immutable objects. So objects are basically references to some allocated memory, and we are directly reading from this part of the memory, and we are changing this memory. That creates some problems. So anything can change at any time. Even if we are calling some method on some other object, we cannot guarantee that it will not change anything else. And in some big enough object-oriented programs where we have some tens of thousands of classes and objects, we really can't do anything without a debugger, where we can actually see the states of objects at a given point in program, and we can see where this program takes us. So as I already said, the objects are direct references to the memory, and this basically unifies the object which is referenced to memory with its value. And as we will see, if we can separate these concepts, it will help us to control the state. So Clojure approach is indirect references. Just as I said before, if object is the direct reference to some data, Clojure approach is to have a box which is a reference to itself. So we can have a value that is immutable, but it contains some state. And if we need to get a value that that can be changed in time, but we need to explicitly say that we need to dereference this object, and then we will get a value, and this value will be immutable. So we got a snapshot of some data structure, and now it is immutable, and we can work with it consistently. It may not be the latest state, but it will be consistent. So how Clojure achieves this? It has some 4 types of mutable references. First one is atom, ref, agents, and vars. Vars are a little bit different from all others because atoms, refs, and agents are shared memory, and they share the values between threads. But vars have their own value in each thread. So the difference between refs, atoms, and agents can be shown as a table like this. So they can be synchronous and asynchronous, and also they can be coordinated and autonomous. So ref is synchronous and coordinated, atoms are synchronous and autonomous, and agents are asynchronous and autonomous. So what means coordinated means here? So it means that we can run some set of mutations as a transaction. So for example, like in a bank account, we want if we want to transfer some money, we really want to make sure that if money was deducted from one account, it is actually added to another. And if some operation is failed, everything should be failed. And autonomous is just independent. Synchronous is and asynchronous is just as in every other language. Synchronous will wait for things to be done. Asynchronous will just immediately continue to perform the next part of the program and run it in the background. So next thing is REPL. REPL is short for read eval print loop. Basically, it is a program that said read an input, then evaluate an input, and print the result. And these three functions are running in a loop. So it was first introduced in Lisp, and now we have REPL kinds of things in many different programming languages, but in Clojure, it's actually a better version. So in Clojure, we can, for example, run all our project in REPL, and we can reload, so we can run the REPL. So Clojure have some startup time. It can be significant, but not very much. But when we loaded everything in REPL, the reload is very fast. It's almost instantaneous. So we can just reload the code that we changed and have everything worked with a new version of our code. No need to compile everything, no need to restart. We just swapping in the new code. And there is an extensive IDE support for the REPL. Almost all Clojure specific IDEs have different kinds of REPL support, and it can be local and remote. So as I already said, we can run entire project in REPL, and our changes can be applied without any restarts, without any delays. Also, we can just send some part of the code segment from file directly in REPL. In this case, REPL may run your project code on, or it may be just newly loaded REPL. So it doesn't matter. Maybe your code segment will modify behavior of your running project, or maybe you just want to see what will be the result of an expression. REPL also is very useful to run unit tests. Can be you can simply start your REPL, and whenever you need to run your unit tests, you just can use your IDE one keystroke, and unit tests that you want are already running. And you can add some custom REPL commands. For example, you just open your REPL and you want to start project. The project's startup command can be, it can have a lot of different components, etc. But most of IDEs have an option to create a custom command, so you can just have some hotkey to start your project. And also a notable feature of Clojure Wrappers is a remote session. So you can send your code to be evaluated on another machine. For example, it can be a development server, some kind of sandbox server where this remote REPL session is running, and developers can connect to this session and have some code executed in it, get some values from the running project in deployed environment. Can be pretty useful. So next major thing that I wanted to talk today is Clojure and Java interop. So Clojure is as Java runs on JVM. Clojure actually partially written in Java. In fact, most of it core is written in Java, and everything else is written in Clojure. So what it gives us is the libraries. Java notably has a lot of libraries for everything, for anything you need. There is a library in Java, and you can easily just use the Java library in Clojure, and it is almost as simple as to use Java libraries in Java, but you are using it from Clojure. In some cases, it might even be simpler. So also you can use Clojure from Java. It's a little bit more rare use case, but you still can do it. There are a lot of ways how you can achieve this. I will show just one example for this. So yeah, also, as I already said, you can directly use Java libraries from Clojure, and it's why Clojure is so popular, why it is so good, because you have all these libraries. But also Clojure have a lot of wrappers or Java libraries, and why it is useful is your Java libraries aren't very functional, and you have a lot of state, a lot of side effects and functions, all these Java objects, but it is really easy to write a wrapper that will expose some pure function API, and it is much faster than create your own library in Lisp. So there are lots of wrappers already developed, and you can use all these libraries. So an example, here we have a namespace. The require is a way to add a Clojure namespace as an import, and import is a way to add a Java package and class. So here we have a namespace where a lot of Java classes are added to this namespace, and an example of usage. So here we have a typical Clojure call. So JSON is the namespace, generate string is a function. We are sending some data structure in it, and it will return a JSON string. Now the date is just the Java util date class. We are creating an object of date that contains a current date. Next thing is, for example, this is a JWS header. This $sign signifies the inner nested class, so we can have an access to inner classes. So dot at the end, it's basically tells us to create a new object. And here is another Java class, and this call is looks exactly like Clojure namespace and function call, but it is a call to Java static method. And next, starting with dot, is a call to Java method. So here we have some Java objects. We are calling some methods, and it's not much different from what we have in Java. This thing with before the variable name is the type hint, so we can actually add some type hints. So as you may know, all Lisps, almost all Lisps, and Clojure is dynamically typed, and Java is notably statically typed. So what we have here is the way to tell Java what class it is, or what primitive type it is, and it will help compiler to avoid reflections that will slow down your program very very much. So you will need to add these types of type hints, and there is a Clojure way to detect if somewhere a reflection was used. It will show some warnings. It is there is a var that turned on and off these warnings for reflection, and it is very useful to check if you are using some direct Java Clojure interop. You should look at the reflections and try to avoid it. It is from my experience, it is always possible to do it. And here is an example of using Clojure from Java. So we have this package and a class IFN, Clojure lang IFN. It's basically a way to represent a function in Clojure. It is a class, or it is an interface actually. Here I means interface and FN means functions. So all Clojure functions are implementing this Java interface. And we can use Clojure Java API Clojure to get an access to all Clojure functions just by using var to get a variable of namespace and name. And then you can invoke this object that is something that implements IFN interface, and it will do exactly the same as it does. The JVM will do exactly the same as it does when you are calling Clojure functions. So now we can say a little bit on best practices. So first one is to use a good IDE. We have a lot of IDEs that are compatible with Clojure. Now we have even more. So next thing is structural editing. Will be explained a little bit later. A little bit on coding style and Clojure idioms. So IDE. First one is IntelliJ IDEA. It is Java IDE, but we have one plugin called Cursive. Also, there is a couple of additional options, but I'm happy with Cursive, and it is really good. It is free for non-commercial use, and for commercial use, it's like $100 per year. Second major IDE is Visual Studio Code. The Calva plugin also enables you with all kinds of Clojure support for repo and everything else you need. And there are some more hard ways to go, so to say. So Emacs is notably written in dialect of Lisp, and it was actually the first IDE that was available for Clojure. So the integration with repo called Cider, but you will need a lot of different kinds of modes and add-ons plugins to make Emacs a good Clojure IDE, but it is completely possible, and I have used it in past, but now I just stick with an idea that has a much better static analysis. And also Vim, just very similar to Emacs, things that it has his own plugins to manage everything that is related to Clojure. You can find some bundles that you can just install for Emacs and for Vim to have everything that you need for Clojure, but using these editors requires some knowledge of them. It's not as easy as just start with conventional IDE. So structural editing. What it does, so we have two options for the structural editing in Clojure and other Lisps. There may be some more, but the major ones are PowerEdit and PowerInfer. PowerEdit basically fixes the structure of syntax and code, the data structure that resembles the Clojure syntax, and you, for example, you cannot delete the brackets if there is something in it. So it will keep all forms balanced. You cannot delete a closing bracket without deleting an opening one, which just won't let you. And there are some special commands to rearrange brackets just like this. So first you have you added some when condition at the top of couple of other forms, and you with just 2 keystrokes you can wrap it around your other code like this. And there are other commands to do it other way around, to move leftmost bracket, to transpose things inside lists, and many other. In PowerEdit, from the other hand, in PowerInfer from different from, so this is from PowerEdit. In PowerInfer, you don't have to write your brackets, and PowerInfer will try its best to actually infer where they should be. The things to note about the structural editing helpers is if you're working with a team, it's highly recommended to use a same one, because it will mess the formatting. And for example, if someone uses PowerInfer and he opens a file, it will immediately reformat it. So not a thing that you want to work when not everyone else is using PowerInfer. It will be hard to have a clean Git history and to remove the changes that are just formatting. So the coding style. First thing that is really important when writing Clojure code is to reduce number of brackets. If they got out of hand, it will be hard to see what's going on. The second major thing is destructuring, and the third is threading macro. So they basically all these things are related to the same concept of reducing number of brackets. So here is an example of threading macro. On the top, you can see a call chain. So function f applied to the argument x, and the result is fed into g function, and the result into h. And you have some number of parents. And here you can just use the threading macro and have only one list that will do exactly the same thing. And thread last will do almost the same thing, but it will set the result of previous into the last positional argument. This will set it first. There are quite a few other threading macros. We don't really have the time to cover everything today, and there are some custom libraries that extend this arrow things even more. So there are lots of syntactic sugar macros like this. So the structuring is the way to get elements from the data structures. For example, this is a vector p and hash map m. You can use this vector syntax and your variable names inside this vector, and to the first variable will be assigned the first element of this vector, to the second the third, and special symbol end, after which everything rest will be added as the name that you choose. The similar thing is applicable for map. Here you have a map with the keys. If your keys are keywords, you have the keys keyword here and the vector of symbols corresponding to these keywords. And here in one, we have one, the first element of the vector. In the rest, we have 3, 4, 5. And in C, we have 3 from this one. So it's shortens the syntax quite a bit. So last thing I want to tell you about is the Clojure idioms. This resembles a correct way of using Clojure and using functions and syntax the way it was intended by the creators. And it makes your code more readable to you and others. So, examples. If you need to concat the result of mapping some function over some sequence, you have the actual function in Clojure that does exactly this. So you don't need to write a code like this. Similarly, when you're filtering some sequence, you have another type of filter that not keeps the functions, not keeps the elements that gives a true result of applying an element to the predicate function over here, but also removes it if the predicate is true, filter skips it if the predicate is true. So you don't need to use not, just use the correct higher order function. So next thing is about collection access. If you want to take first of some sequence, and for example, the first element of the sequence itself, and you need the first element of this, there is a Clojure function to do it. Same with similar things. This is an example for into. So this example of how to map over the hash maps, actually. So here you have you want to have a hash map as a result. So the map will always return you a sequence. So you're setting it into the map, but you have the idiomatic way of doing it by using reduce KV. And there are a lot of idioms like this. There is quite a big set of it in the link below, and they are very good. There are very good explanation of this. So we finally came to Q&A session, and if you have any questions, you are welcome to ask them.
Thank you, Kostiantyn. I'll just remind to use chat and Q&A and raise hand for some questions. Okay, there is a question from Dan here. So what is the use of macros in Clojure? Briefly.
So the use of macros in Clojure is basically to expand the syntax of the language. So when we want to have some syntax that is not supported by the core of the language, we can use macros to extend the language itself. So we will be able to add an additional stage to program evaluation, where the macro will be evaluated and it will be resulted in a chunk of code that then will be evaluated. So it's to extend the language syntax.
Did we respond? Okay, let's think that yes. Oh, okay, thank you. And there is another question. An example of when Clojure is much more beneficial than other well-known languages. I was waiting for this question. And the other question, how it affects the timing of delivering ready solution? Great question.
Sure. So the example when Clojure is better than any other language is quite a complex one. So there may be some language for some exact use case that is can be better than Clojure, but in general, why Clojure is better is because you can. It helps you to manage complexity. It helps you to manage state. So if you have a really complex program, you can make it much more simpler just because you are using Clojure, immutable data structures, and pure functions. So it's not the unique thing to Clojure, but together with dynamic typing, really very powerful REPL, it enables you to write things much faster. For example, there are some benefits to languages like Scala. So they have additional checks on compile time for the program, but the writing code in Scala is like half of the time you are just struggling with the compiler, with the type system to get it compiled. So it will add you some guarantees to that your code will be at least free of some runtime errors, but it will take much more time to add all required types and to make all the types work together. So what makes Clojure faster is you don't need is a dynamic typing. You don't need to write another program with a type system, basically.
And just to sum up from myself, well, Kostiantyn was, praying to REPL through the whole presentation. So it's REPL, definitely, it's simplicity, it's concise, and it has probably less, if I can put it in this way, it has less other languages bureaucracy. So it's like, this fast feedback that we declared in the title of today's webinar. Okay, let's move on then to other questions. In the chat, we have in the chat, which tools are more often used on real projects and which are not? I guess with Clojure.
This is a quite a difficult question, because different projects requires different types of tools. So it's hard to answer this, because, well, we have, for example, almost every project needs to have some kind of component management tool. So I would expect this one to be in almost every project. So most of the projects have some servers in it. So you will have some library for web server, a library for routing, but you always have some different options with Clojure. You can choose for yourself what is better to you. So in the past, all the routing was done with Composure. Now we have Pedestal, which have some upside and downside, but so you have an options how you want to write your routes. If it can be, for example, macros like in Composure, or it can be just the plain data structures like in Pedestal. What is I'm not sure that there is a library that is like must have for every project. Every project is it can be completely different. So there can be a project that does not require any web server and it does something completely different. You can do a number crunching in Clojure. So there are ways to use GPU from Clojure. Obviously, these kinds of projects will use quite a different set of tools than the web ones. I hope this answers the question.
Okay, thank you. And I believe we didn't answer the second part of previous question, how Clojure usage affects the timing of delivering ready solution.
Oh, of course. So the benefit of Clojure here is, I think I partially answer it because I already said REPL and dynamic typing lets you write a program like in a day. So Clojure is like star of all the hackathons where all kinds of programmers are really like to use Clojure when you are even you have a limited time to create some kind of project. So you can create a fighting game just in a day, basically. So obviously it can be used to get a quick result. but on the other way, it also can be used to provide robust projects that are well maintained and working without any failures. So it's just what you need to do when you need to do a quick design. You can do it, and you can update it, make it more robust. In for example, other functional programming languages like Scala or Haskell, you don't really have these options, because you will spend a lot of time on defining your types. It is really very time consuming, where in Clojure you have an option to not to do it and add validation where it crucial.
Yeah, and to add something to that, so basically it's dramatic, right? And also it allows you to experiment.
Yes, sure.
Because the time is the matter there. We have one more question in Q&A. What advice can you give to those who want to start studying Clojure?
Just start reading some Clojure books. There are quite a lot of useful resources online. For example, Brave Clojure is a good one. There are lots of exercises you can find online. Do some exercises, get used to syntax, get used to this programming style, and you will find it much simpler than other programming language shortly.
Are there any other questions? All right, I believe we are out of time, right? And I just wanted to thank everyone for attending and being with us. If you want to paste any last time questions, I guess you can contact Agiliway and ask them as a follow-up. And thank you all. Thank you for attention and attending.
Thank you, everyone. Thank you for questions.
Goodbye.
Bye.